Overloading. This is a sort of intermediate to advanced concept in programming that can be very powerful but also can be quite confusing. Today, what we're going to do is we're going to just delve deep into what overloading actually is, as well as to look at its pros and cons. You're watching another Random Wednesday episode on 0612 TV. Hello and welcome back to another Random Wednesday episode. We can just jump right in today to the fundamental question of, well, what is overloading? Simply put, overloading is when you have multiple function definitions with the same name, but they differ in terms of the arguments that are actually passed to them. And this can be, in terms of the types of arguments or the number of arguments. Here's a very simple example of this in action. Here are three different add functions in Java. The first one adds two integers, the second adds two floats, and the third actually adds three integers instead. This works because later on when you actually make a call to either one of these functions, the programming language is going to look at what inputs you've supplied and infer which one it should use. What we've just seen is a very simple example of overloading. In fact, it is what is known as method or function overloading because, well, we're doing it to a function. Another type of overloading actually exists, and that is called operator overloading. And as its name implies, we are basically overloading an operator, like, say, the plus sign, which, by the way, is overloaded by default. In many programming languages, well, when you use plus with two numbers, you are adding them together. But when you're using it with strings, you are concatenating the strings. One operator, two different purposes depending on the input that is being supplied. And that is overloading. As you can imagine, this is extremely powerful in terms of abstraction. You now don't have to think about, the underlying implementation of a particular function or a particular operator. You just use it and it works as you expect, without having to think about the types, for example. One particular type of function overloading is constructor overloading, and that is when you're doing object-oriented programming. Well, you can construct an object in one of multiple ways. So yeah, this just gives you more freedom and more control. Of course, there's one caveat to this, and that is the fact that not every programming language actually supports this. Programming languages like Java support only functional overloading, but not operator overloading, whereas languages like JavaScript basically support none of that. So yeah, while this is a very powerful feature, we do have to sort of understand its limitations and the problems it can create as well. Firstly, there is a practical concern of code duplication. For example, in our earlier example, well, we basically re-implemented add 3 times. If we wanted to change something about this function, we're going to have to implement this change 3 times. Of course, this can be worked around, and one way to do this is to basically create a master add function, and the rest of the add functions have to depend on this. It makes things kinda unwieldy, but it works, and it does take away the problem of code duplication. Another problem can arise when you're not so sure of the types. Some programming languages actually like to sort of change the types for you when, it's necessary. And what this means is you may expect to be passing in an integer, but later on realizing that, hey, the programming language has converted it to a float. This, of course, can create ambiguities as to which overloaded version is actually being used. In fact, you're seeing this happen right now. This was my code for addition earlier on, and well, there was an error because when I entered a decimal number, it got interpreted as a double, not a float, and as a result was not able to trigger the function I had written. Operator overloading creates even more challenges. One example, of course, is when it's actually unclear what a particular symbol does. One good example is the caret operator. Now, we are pretty used to that actually referring to, doing a power operation, but in many programming languages that actually means XOR, bitwise XOR in fact. So yeah, this can be unclear, and things will be even worse if we actually make certain assumptions that end up being untrue. One good example of this is seen on the Wikipedia page for operator overloading, and that is the fact that this particular property, the commutative property, which we assume holds, actually doesn't hold if the plus doesn't mean the plus we expect. For example, if plus actually refers to string concatenation, then it's certainly not a commutative operation. So yeah, hopefully these examples sort of demonstrate to you that you have to be careful when you're doing overloading. If you can create some kind of ambiguity, it's more advisable to not do it that way. Just use multiple functions with different function names so as to not create confusion. Now, there can be some other confusions in theory as well. In fact, overloading is a kind of polymorphism. But polymorphism is a term that we tend to associate with object-oriented programming. Overloading, however, has nothing to do with OOP. You can do overloading in a language that doesn't support OOP at all. In fact, polymorphism is a very broad term, and even though we hear it associated with OOP a lot, it can actually be used outside its context, so it's important we don't get confused here. It's also important to take note of the times when we are not actually overloading, even though it may seem like we are. One example of this goes back to OOP. In inheritance, what we can do is we can have a class that defines a function, and then have an inherited class that basically re-implements that function slightly differently. This might look like overloading, but is in fact overriding, not overloading. Because what we're saying is when we call this function on the inherited class, we want to run the new version, not the one actually defined in the parent class. So hopefully you can see why this is confusing. Ultimately, we are kinda doing the same thing. We are redefining a function that uses the same name, but acts slightly differently. But in this case, because classes are involved, because inheritance is involved, the meaning is different. This is overriding, not overloading. Here's another situation. These are two different functions that have the same name, but will in fact give you a compilation error. The reason for this is, well, the differences are only in the return type. We cannot do this. Don't forget that your programming language basically chooses which version of the function to use based on the inputs. However, in this case, the two functions have the exact same set of inputs, and they only differ by the return type. Your programming language cannot actually make this decision, so it doesn't actually allow you to do this. This might not be immediately obvious, at first glance, but yeah, this is actually a problem. So yeah, there you have it. That is the concept of overloading. It is a very powerful tool, but be careful to use it right, because otherwise it gets really confusing. Anyway, that's all there is for this Random Wednesday episode. I hope you gained some insight today, but until next time, you're watching 0612 TV. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.